Alright, and our last example here, Ration leaves his car in an empty parking lot and walks 25 meters east. Okay, so hang on. We got a car. I don't know how to draw a car. There we go. Car. He's got a car. He leaves his car and walks 25 meters east. Okay, so that's a distance of 25 meters along the aisle he parked in. Then he turns and walks 60 meters. I didn't plan my picture well because I thought he was going to walk south. He walked north. I have to draw up. Okay, so that's 60 meters. He went north. So now he's up here. Alright, at the edge of the parking lot. How far and at what bearing has Ration walked from his car? How far? Okay, so how far is going to be this distance? So what we want to find first is, I'll just call it D for distance, is this distance. How far? Can use the Pythagorean theorem since this is the right triangle down here. So I'm going to use the Pythagorean theorem to find D. We know that 25 squared plus 60 squared equals D squared. So we can just use our calculator and get that calculation. 25 squared plus 60 squared is 4,225 equals D squared. If I square root both sides, the square root of 4,225 equals D. I could probably divide that by 25. Ooh, and maybe it's a perfect square, actually. Let's see if 425 is a perfect square. It is. It's 65. Excellent. I didn't know that at first, but I divided it by 25, and I got 169, which I knew was 13 squared. So then I realized I could take the square root of the whole thing. Just cool. So that means that he is 65 meters from his car. At a bearing of, hold on, we don't know yet. We need to find the bearing. Okay, so the bearing from the car, what bearing has he walked from the car? So the bearing, remember a bearing is an angle that is from north counterclockwise down. So this is the angle that I'm looking for. I'm not looking for the angle inside the triangle this time, I'm looking for the angle outside of it. There are two ways that I can find this. One, I could find this angle down here and then subtract it from 90 to find the outer angle, or I could find this angle up here, which is going to be the same thing. Okay, let's go ahead and find this angle. This is the angle that is going to match the bearing, which is the outer angle out here, measured from north from where the car's position was. Alright, so let's call that angle theta. Our bearing angle is going to be theta. And because I know the 25 and the 60 from that theta were the opposite and the adjacent, we're going to use tangent again. So the tangent of theta is equal to 25 over 60. That means that our theta is going to equal the arctangent of 25 over 60. Alright, calculator or Desmos, doesn't matter. So arctangent, don't matter how I type it, if I write ARC or damn with a little negative 1 in the corner, I think this is cleaner, of 25 over 60 gives us an angle of 22.62 degrees. So at a bearing of 22.62 degrees. Okay, that answers the first part of the question. The first part of the question was how far and at what bearing did he walk from the car? Part B, if he then walks an additional 40 meters due east, what direction and how far will he have to walk in order to get back to his car? Okay. Alright. So he's walking east now. and he's walking 40 meters east. So now he's going to be over here. So we're creating a new triangle like this. All right, this distance on this side is still 60. This total distance across the bottom, since he walked 40 additional meters east, this total distance across the bottom is that 40 plus our 25, so it's going to be 65. All right, so in which direction and how far will he have to walk to get back to his car? All right, so the first thing I can find is how far, and that's using the Pythagorean theorem on these two things. So let's find out how far. So how far? The new distance is going to be 60 squared plus 65 squared. So 60 squared plus 65 squared is d squared equals 7,825, and the square root. I'm going to assume that he does not want us to give him the actual simplified square root, so we'll go right on to the decimal so we can tell this guy how many meters he needs to walk. This is the square root. I'll write the square root first. Square root of 7,825. And so that distance is approximately 88.459. Okay, so his car is, we'll summarize in a second, 88.459 meters away. And in which direction will he have to walk? This is where I think we're going to change up something from the last one. Last time we asked what bearing has he walked from his car. Since he was walking from his car, his bearing was considered to be this angle. Now he is at a different position. He is him over here. If we want to talk about what angle he has to walk, we're going to talk about the bearing that he would need to walk. So if he had a compass, for example, the bearing that he would need to walk is going to be the angle that goes this way. Okay? So to find the angle that he needs to go this way, we'll be finding this angle. And then for bearing, we're going to add up the 90 degrees from these two quadrants to get this angle right here. So we are going to be finding this top angle. And then similar to what we did here, and then we'll talk about bearing by adding on that 180 for that straight line distance. Measuring from north would give us a bearing that's going to be bigger than the acute angle. Okay. So first, we're going to have, this is an opposite over adjacent of 65 over 60. So we're going to start with a tangent of angle equals 65 over 60. And then we can arctangent that ratio to get the angle. And I'm just typing this in, so that gives me arctangent of 65 over 60, an angle of 47.2906, so 0.29 degrees. I just typed in the arctangent there. Okay. All right, so his bearing would be plus 90 degrees twice, right? Because each of these quadrants up here is 90 degrees. So if I add 90 degrees twice, that converts our angle into a bearing angle. So that would be 227.29 degrees. So in conclusion, let's see, it says how far will he have to walk in order to get back to his car and in what direction? So he needs to walk, assuming he can get there directly in a straight line distance, he needs to walk 88.459 meters, at a bearing of 227.29 degrees. We use bearings because that is how you would measure on a compass. The compass angle would be from north. You want your angle to be at 227 degrees from north.